You know, as an engineer, I always had the perception that the rules and the regulation is something rigid that comes top down and then everybody else has to follow. Now I observe more and more how dynamic this actually is. You know, it's the industry and the capabilities that a country has that drives the regulation.
Hello, welcome to the Space Policy Show. I'm Colleen Stover with the Aerospace Corporation. Today's show is the next episode in our six-part series about space safety through a global lens. Can you imagine a future where there is zero space debris? Well, the European Space Agency is challenging the space sector to do just that. Well, it's not exactly zero, but it's pretty close. Today, we talk to Holger Krag, head of ESA's Space Safety Office, about their Zero Debris Charter, now about 1 year old, and the importance of baking in debris mitigation strategies to new space missions, as well as efforts to remove debris that's already up there. He's talking to Aerospace's Marlon Sorge, a partner here at the Center for Space Policy and Strategy, and a world expert on debris and SSA, or Space Situational Awareness. Let's get started.
Thanks, Colleen, and thanks, Holger, for being with us here for this discussion. Obviously, one of the big things in the community right now is ESA's zero debris policy. I was hoping that you could give us an introduction to the zero debris approach. What are you really trying to get at there? What are you all trying to do?
Yeah, no, thanks, Marlon, for having me and talking about this important topic indeed. Now, ESA wanted to move some steps ahead with the zero debris approach. Now, if you listen to the word zero, it sounds like there will be absolutely nothing afterwards. No, what we mean is significantly going beyond the state of the art of debris mitigation requirements for our missions. And that particular means leaving nothing behind of our space missions for the things that we have under control. So the first things concerns the disposal of our objects that we want to see to be fully successful, 100% at a certain stage. If you look at what we are suffering from in the environment today, it's basically a result of failed mitigation actions. All the fragments that are around us are a result of cases where we fail to passivate objects, preventing them from explosions that in the end happened. Or collisions, which happen because things are left in space for much longer time than they should be. And that's the prime point we want to address. The missions that we have under control in ESA, and these are quite some. We are not the biggest operator for sure, but there's quite some missions. For those, we want to make sure they are not left behind by all means. And we come back maybe later. It even means we have to do drastic things like removing them actively if a disposal action, for example, has failed. But we also want to go further, improve collision avoidance beyond the state of the art, improve the trackability of our objects, make sure that passivation becomes more fail-safe, so much better than 90% likelihood that we have today, bringing it much closer to 100%, and look at also the residual lifetime in orbit. As you know, after space objects' operational life is over, it should actually leave space. But how much time do you give it to leave space? And today, 25 years or 5 years are the rule. But we find these numbers very rigid, because if you have a very big and critical objects, you might want to remove it fast. If you have a very small and less critical objects, it's acceptable to have it for 5 years or maybe even a bit longer. And the way we see things is that in the zero debris approach, this should be driven by the criticality of the object, which in most cases means to be leaving space much faster than 5 years.
So given that the goal of the zero debris approach is to really push ahead, what are some of the specific areas where you're going beyond kind of the sort of existing rules, such as the guidelines from the Interagency Space Debris Coordination Committee, or the standards from the International Organization for Standardization?
Yes. I take three examples where we would like to go beyond the current state of the art, if you will. Number one is the success rate to bring our objects down after operations, so that to make them leave space, to dispose them. Today, the success rate needs to be at the level of 90%. That's the state of the art. We believe we don't even reach this technically today, and even if we reach it, we believe it's not sufficient. So we would like to see basically certainty in our disposal action. And therefore, we are asking, for example, our objects to be prepared to be removed by having the right features on board that allows another vehicle to come, capture it, and bring it down. And so to have a fail-safe disposal. The second example is passivation. Passivation are all the mechanisms you have to have on board to make sure that residual energy is depleted, preventing explosions because of residual fuel, residual gases, or pressure gases on board. And that also is required to be at a 90% level. And that is going to go up to 95% in our zero debris requirements. Now, the third thing is that we would like to make sure that our objects don't stay in space for not more than necessary. And that is not driven by a fixed number of years, but that is driven by the criticality of the object, by, for example, the orbit it flies in, or the size the object has. So a big object in a high orbit is not a good thing. It's very critical for the environment. So there, even 5 years of time and space after the mission is pretty long. So that should be shorter. Whereas a very small object in a low orbit, that can be tolerated to stay there for 5 years longer than the mission is. And that's how we see things. So we are sort of adjusting the allowed extra time on orbit after the end of the mission to the criticality of the object.
Right. Yeah. Thank you. And so one of the things I noticed about the policy is that the goal is to kind of have things implemented by 2030. Was there a specific reason for that, or just that's how long it's going to take?
It's good to ask because where does the 2030 come from? No, it's a bit random, but not totally random, because some of the things we are asking requires extra technology. So we are going very far down the route. We have very demanding technical needs, and they are not always available. So we cannot, at the moment, ask these things to be applicable straight away, although we would wish to. So we need to give time for technology to mature, to bring up the passivation up, to get the technology to remove objects in space after they got stranded. It needs to be demonstrated first in space before you can ask it, because otherwise you take on board unreasonable costs and risks. So this is the reason why we need some time for some of the requirements to come in. And the total truth is that we are not waiting for 2030. We start with the more reasonable requirements already now. So as of 2024, the first step of the zero debris approach is already applicable law, if you will, for the ESA missions. And in a few years, we will see a second step. And 2030 really is the final step where we go for the really, really difficult requirements.
So given how much the zero debris policy is moving forward, one of the obvious questions then is how have you gone about implementing the policy and the requirements? That's always a challenge with something new.
Yes, that's right. First of all, you have to convince those that have to fund the requirements, because these requirements come with cost. This is the case for all requirements. ESA has a variety of programs ranging from science to Earth observation, human spaceflight and launches. So these would have to endorse the same set of requirements and make them applicable in the standard reviews. But there's also industry. Industry is the one that implements our mission, that builds a spacecraft. So they need to understand, they also need to endorse, because if one agency goes further than the others, they find themselves in a situation where they need to deliver something different to ESA as compared to others. So this is something very, very important. And actually, it was our starting point. Our starting point was industry. Is there a consensus that we can achieve with industry of what is achievable in the near term? And it is actually the case that we built this roadmap together with industry, and from there propagated it into what we call the programs, and in the end, management approval. And now it's a standard process in each and every new ESA missions. These requirements are part of the applicable documents, and a standard review process will make sure they are implemented. Yeah.
Yeah, I have to admit I have a selfish reason for asking that as well, as of course the U.S. is thinking about where they want to go with policies as well. So anything we can learn from some successful endeavors is definitely a help. And I had one more question about the zero debris policy before we actually get into the next topic I want to talk about, which is industry, which you started on there. Is slightly outside of the debris standpoint is the area of dark and quiet skies, which was also included as part of the zero debris policy. And do you talk a little bit about how that made its way in, why that's in there as well?
Yeah. Now, I'm glad you bring it up because it's a topic often forgotten. And for us, this is a very evident topic. First of all, even inside my area of responsibility, I'm using a lot of optical telescopes to find dangerous asteroids, near-Earth objects that might encounter our Earth one day. And they need to cover wide portions of the sky with a big field of view at twilight. And that's the time of the day where you see most of the satellite traces on the pictures. So we are directly, I would say, suffering from the problem. So we see the impact of a sky that is not dark. But we also get reports from our science missions that even space flying telescopes have very, very bright flashes on their images. It's not, we should not over dramatize it as well. Today, the situation is not, you can do astronomy, but of course the trend is that it gets more difficult. So this is why we have some first-hand experience, but we are also approached by astronomers. You are a space agency, can you do something? And by the way, this is not only optical astronomy, this is also radio astronomy with even more sensitive instruments suffering from the RF communication and also other RF channels coming from the spacecraft. So this made the topic come into our requirements. The answer to this requirement is by far not obvious. What do you do? Making a spacecraft darker might help to give a better impression of the night sky to the observer without instruments. But for an astronomer, it does not help a lot. There, better predictability would help. And for radio astronomers, switching off transmitters over certain stations could be a solution. But I have to be honest with you, Marlon, on this one, we are still developing what the actual requirement will be. It's one of the topics we have moved a bit further down to 2030 because there's a lot of help we need from the community on what kind of options we actually have.
Well, it's good to hear that we're not alone in the fact that it's definitely a challenge. Certainly, the big field of view telescopes that can see a big swath of the sky, they're a revolution in astronomy, but definitely a challenge in terms of trying to figure out how to deal with all of this new space activity.
Yes.
So, yeah. So I wanted to get back to the whole discussion about industry. I mean, obviously that's been one of the huge changes recently in space is the amount of activity that's going on from the commercial sector versus just being government. And as you mentioned, having industry involvement in any kind of change is absolutely critical for actually making it work. So you started talking about how industry was involved, and that you'd gotten them from the start. Could you go into that a little bit more?
Yes. The requirements we are adding will trigger cost increase to missions. But that cost increase is not necessarily constant throughout time. We rather see it in the way that you have to do an initial investment that will bring your platform, your spacecraft standard platform, to the next level, to, let's say, more safe and sustainable level. So it's a kickoff investment that you would have to do. And the offer to industry is, let's do that investment through the agency. So you're through the agency contracts that you are getting, we make sure you are resulting with a platform that is on the next level and compliant to these next level of the requirements. And then whenever you reproduce your platform for commercial applications, you can basically benefit from all the developments that were made for free, and sort of propagate these requirements automatically into the other missions without extra cost. That is the idea. And I think this is the principle that worked. And of course, then it's a matter of discussion. What should these requirements be? What is really achievable? And also what is ESA or agencies are ready to do. And there's one thing we should not forget, because of course we're also getting the question from industry in particular. Marlon, as you can imagine, what is the purpose of one agency moving forward with this if the rest of the world doesn't follow? Yes, and that's a valid point. You can imagine that's not easy to answer. When the platforms are available, that's already half of the story. But the other half of the story is to also see if other regulators would not be willing to follow similar steps. And of course, there's no means as ESA we can ask others to follow the same steps, but we can invite the more ambitious agencies and regulators in the world to follow suit by what we call signing up to our charter, which is a bit of the coalition of the willing. It's not mandatory, but if you sign up to that charter, you're documenting at least your interest and will to look at something similar like ESA's zero debris approach. And that gives extra assurance also to industry.
Yes, yeah, that is definitely always a challenge, trying to keep everybody's rules at least close to each other so that you don't get that kind of inequality in there. And one of the things that we've seen here too is that in some of the areas, industry has been moving out in front as well, in terms of some of the best practices they suggest and things like that. And I was wondering on your end how the industry response has been to your approach.
Overwhelming, I must say. I can see this directly. I can read this directly when I look at the registrations to sign up to the charter. There are more than 100 parties that want to register, and many of them are industry. And I believe the charter that we are talking about is going much further than, let's say, the most of the approaches that you see being signed by many in these days, because the charter contains real numbers, requirements as you know them. You are an engineer, so you know how concrete a requirement can be. And the charter is quite explicit on what to ask for. It's not using many words, it's using more numbers. And I find it astonishing to see so many signing up. So we see a very, very open-minded industry embracing this. And we hope also that those that actually have to take the decision and do the regulation would join in with the same numbers.
Well, that's definitely good to hear, and I think as an example, being able to hold that out and say we have offered up moving forward, industry didn't resist. It helps to eliminate, I think, one of the real concerns that there often is with advancing some of where we're trying to go with preserving space. So I guess you get to act sort of as the guinea pig for that, but that definitely can have some benefits there.
We do our best.
So another one of the things that I have to say, looking at it from the outside is always a challenge, is sort of understanding the structure of European space in general. And so one of the other questions, obviously thinking through this, that came up is how does ESA's safety program, all the efforts that you've got going there, and the EUSST effort, which obviously has some overlap, some complementary stuff going on. How does that all fit together?
That's a good point. And I fully can understand your position that it's difficult and not very transparent from the outside. But let me do an attempt and explain it. So the EUSST is the European Union's space surveillance and tracking activity, which is the European Union has different member states than ESA has, and they have their own regulation and funding sources. And operational space surveillance and tracking is the mandate of the European Union. And that is something they do with their member states in an operational manner. Operations means to use sensors that are existing and actually produce actionable services like collision avoidance, re-entry prediction services out of that sensors. The space safety program, which I'm leading, is an ESA program where we do have a mandate for the development and operations of planetary defense, so asteroids, telescopes to observe these asteroids and risk list on asteroids, space weather, the observation of space weather and the preparation of services for space weather, and the development of space debris solutions like active removal, like passivation technology, and many things of that alike, and also sensor technology for SST. But the operations of these sensors to provide actionable services out of that, this is not part of the mandate. There we hand over to the European Union's SST, and that goes hand in hand. So it sounds like two competing programs, but it's not. One has a mandate more in operations. The other one has the mandate more in research and development and bring about missions to fly. And we are actually working together because the European Union's duties on space weather and planetary defense, they are fully entrusted to ESA, and we are handling that out of one hand in a very complement and coherent way.
That's very, very helpful explanation, just to understand how all of the pieces sort of fit together there.
That means you have understood it, which is a good sign.
Yes, thank you.
But it's not completely impossible to understand. This is really good. Yeah.
So in the whole development of the zero debris policy and in the discussions that we've had so far, we've talked a lot about the whole area of mitigation, trying to keep things from exploding, getting things out of orbit. And you've mentioned, and I know this is a big effort as well, the whole concept of active debris removal, being able to go up and take something that's already disabled or dead and getting it out of space. And again, here, this is a place where ESA has really been pushing forward. So, could you talk a little bit about the Clear Space 1 mission, what that is, and where the progress is right now?
Yes. No, thanks for bringing that up, Marlon. Indeed, the Clear Space 1 mission is our way of demonstrating that active removal is possible. It's going to work with a real removal target. So we are bringing down a target that is already up in space. And we do that with industry that is also prepared to do that repeatedly in an operational and also commercial context. That's very important. The question, who pays? We will have to answer that, I guess, in a minute. But first of all, we are convinced that technology informs regulation. So you cannot regulate what is not demonstrated technically. To break the ice, we need to go into space and show that it can be done. This will be the ultimate proof to all that the poor people that have to write the regulation that there's no more excuse to wait for a technology. It is now there. We can do the bold step and ask active removal to be used as a mandatory measure. we see it to be a mitigation measure. We see it as a way to fix retroactively a failed disposal. And that's very important because there's many legal constraints. You will have to make sure there's somebody who pays. And that's the way to get it. And it solves, by the way, a problem because today we are leaving by far too many objects behind in space that are not properly disposed. Once this is all in place and the technology is getting cheaper and more proven, yes, it's also possible that we go to objects that have been in space already for decades, where nobody feels responsible anymore, anyhow. But we would like to start with a clear rule, which you might know from a national park. So the things you bring in, you need to take out again. That's a rule we want to put on our missions. And there you have an owner, you have somebody who has to pay, and things are very, very clear. You also have no legal problems because owner and remover are belonging to the same entity. And that is something you can factor in already when you plan the mission. This is what we want to demonstrate with the ClearSpace One mission.
Yeah, and that approach seems entirely consistent with the rest of the approach you were taking of saying, okay, well, we're going to step up, help with the initial investment, make something possible. In this case, really just even demonstrate that it can be done. And that will potentially open up, make it easier for this to become regular. And as you mentioned, there's always the question of who's going to pay for ADR, for active debris removal after we do these demonstration missions. And I don't know that there's a straightforward answer to that, but I guess phrasing that, one of the new things that's come along, of course, is in space servicing, manufacturing, and logistics. And I guess one of the questions that I've been thinking about that I'd like to get your inputs on is how might the developments there help make it easier to have a more regular active debris removal effort?
That's a good point. I didn't reflect so much on that backward feeding of in-orbit servicing into active removal because we see active removal rather as a first stepping stone, technically, before you go into more complex interactions in orbit. But definitely you have that in both directions. But the repeating, and you also made the point very clearly, and this is a question that needs to be answered. What is the market for active removal? The way I see it, yes, there might be voluntary removal actions, but probably not enough to sustain a commercial market. I believe that we need this, what I call zero debris approach or rules of the road in national park rule, take out what you bring in, must become a mandatory requirement in mitigation actions. It's de facto equivalent to say, you need to make sure that your object is disposed, not by 90%, but by 100%. If you're asking that, you make that part of the mission, and therefore you have a market because people are required to do it. Is it expensive? Yes, it costs money, but maybe not that much as you think. Because if today the likelihood of failing disposal is 10%, you only have to pay 10% of the recurring cost of a removal action if you take, for example, a right insurance, and insurers in between that dampen the risk for you. The premium that you would have to pay would be on the order of these 10% of the mission cost. And then we are talking a very low amount. And we got to the conviction that for our missions, this is something we may do.
And it certainly gets to what we all know in the community is the fundamental problem that you were talking about earlier, is you can't leave stuff in orbit if you want to be able to keep the environment under control and keep it manageable. So this definitely would see some significant progress in being able to get to the point where we can actually do it 100% of the time.
Yeah. And to come back to the more far-reaching actions in orbit, I agree that we shouldn't stop with active removal, because further down the road, the roadmaps foresee then, of course, once you rendezvous and catch an object, you can also sustain its longer life. You can refuel it, or you can extend its lifetime. And then the question, if there's a market, is very obvious, because then you have a paying customer that is interested in having a longer or more output of his mission, even if the fuel is already spent. So we are going that route as well. By the way, even with the customer. So we will fly a mission in the next 5-6 years, which will extend the lifetime of a customer spacecraft in the geo orbit. And that creates a sustainability effect as well, because you don't have to launch a new object. You can operate that one longer, and then afterwards you can remove it even with the same vehicle out of the critical region. That's what we call circular economy in space.
Yes, yes, and that was part of my thinking about some of this as well. Is if you build that, if we're able to build that infrastructure, that then getting around space becomes easier, and suddenly one of the challenges of ADR becomes easier as well. So, definitely hope that the interactions between all these efforts will really compound and kind of get us where we want to be faster than if we had to do it individually.
And what you just said reminded me that the availability of this technology triggered already some interesting requests to us, because people are asking, look, if there's a removal service available, it might be much more convenient and even cost effective for us to not build in certain functions into our spacecraft. For example, the function to do a controlled re-entry, which is very expensive and complex to do, if there's a service that can take that over from outside. So suddenly you find that technology might enable a bit of changes to the way we do certain platform constructions and building, and who knows what will come if that is successful.
Yes, definitely. It's very, very exciting to see that. So given that it's been about a year now since the charter has been out, I'm wondering what overall progress, kind of what good things you've seen come out of it. What are still some of the challenges that remain to get where you want to go?
We don't see a major obstacle yet. We see a good onboarding of these requirements in the ESA missions. But it's too early to judge, Marlon, because in the end, you will have to see, how long a space project takes in a life cycle. You don't introduce a requirement to a mission which is already in the middle of the development. So we are introducing our requirements, to be fair, to the missions that start the development. And then a development life cycle can take 4 or 5 years, and then you will have 5 years of operations. And then you will see the effect of what we ask in these requirements, because space debris requirements kick in the end of a space mission. So we need to give it a bit of time and observe how well they are implemented. You might say, well, but that's no guarantee of success. Yes, that's true. But remember that a part of our requirements are formulated in a way that they are made fail-safe. Think of the requirement to remove the object at the end of the mission, no matter if it's by their own means or by an external means. And this is the way we generate also, let's say, confidence in the fact that in the end we will get what we ask for, and that is the zero debris aspect of what we are putting forward.
So on the sort of the policy and acceptance side, you'd said that you'd actually gotten quite a bit of positive reception for the charter from industry, and I was curious also, along with that, what kind of response you've gotten so far from other agencies, other governments, noting that they tend to move much more slowly than industry does, and tend to be, I don't know, happier if they see some demonstration of things before they move forward. So I caveat that, noting it's only been about a year.
That's right. But, as an engineer, I always had the perception that the rules and the regulation is something rigid that comes top down, and then everybody else has to follow. Now I observe more and more how dynamic this actually is. You know, it's the industry and the capabilities that a country has that drives the regulation. So a certain capability, the things that are technically possible, they are changing the regulation. If there's a new capability, you will update regulation. So and that gives reason for a lot of hope. So with that technology coming, and there are several countries where active removal service providers are developing their missions, and of course they stimulate the way the regulators are thinking in the country. And if a country has both a large constellation and an active removal service provider, and perhaps even a good insurance market, it's even a win-win-win situation for all three sectors to bring forward a more ambitious law. So here, I must say, I'm very hopeful that also member states, even if they don't use the wording of the zero debris approach, it doesn't matter as long as the idea is shared largely and then propagating into the national regulations as well.
It's very exciting to see. I mean, as long as we've been working in this area, to actually see some of this real progress, the amount of participation that's going on is I think really hopeful for being able to get the world to and space in particular to be kind of where we've been trying to get it for all of these years. So I really appreciate you coming on and talking about all of this. It's fantastic to see it. Thank you again very much. I appreciate it. I will hand it back over to Colleen.
Thanks, Marlon, for having me. It was a pleasure.
All right. That was a good introduction to ESA's efforts to drive space sustainability through community initiatives and through tech demos. I expect more to come, so stay tuned. Marlon and Holger, thank you for being on the show. Other topics in our series on space safety through a global lens include weather, rescue, launch, and more. So check them out. They're all publicly available on YouTube or by podcast. We also have other 6-part series on ISAM, in-space servicing, assembly, and manufacturing, and contested space. You can check out the center's other more in-depth research papers at csps.aerospace.org. James Liggins is our technical director. Thanks for joining.